Hello, everyone. Today, do you have any question for me? We can go over your question first.
I can't
Yeah, Miguel,
I can't think of any particular ones. I'm still
are
still
you
trying to
working
figure
on
it
chapter 8?
out. I'm only just starting chapter 8. So
Just
I'm
started. Okay.
yeah, I've been traveling, so I'm a little behind. Uh,
Uh-huh.
One thing I was gonna ask,
Uh,
uh, the M MO7 homework is closed, and that was the central limit theorem.
that is the central limit theorem. Yeah, that's right. You
And
only need to apply that formula to do
yeah, and
standard deviation. Yeah.
I didn't finish it because I was
Okay.
at
I
work.
can
And
homework. I can reopen
um,
it. It's fine. Yeah.
yeah, even if I don't get the credit, I need to sort of practice it by doing
Yeah.
the problems.
No, it's good in
If you could
practice.
reopen it, that would be
Great.
excellent.
Yeah, no problem. Yeah.
Okay.
So because chapter 7 is related to chapter 8, chapter
Chapter
9.
8, yeah.
Yeah, so far. Yeah. So it's
Um,
good to finish that one. Yeah.
yeah, I mean, I understand
Uh-huh.
the concept of it,
Hmm.
but I have to work my way carefully through it because
Yeah.
I just lose my way with these things.
Ah, actually, no problem. We can just take one questions as an example, so then you can understand. Just
Okay.
apply the central limit theorem. That's all.
Yeah, the
Okay.
central limit theory.
Mm-hmm. That's the key. So in chapter 7, the most important part is that. And
Yeah.
it is a standard deviation. We need to do something. Okay. We can grab some, we can
Now let me see
go
if I
that the homework assignment in that section. If you have one particular one, we can take another one uh, to
I
work
don't
on,
because I
right?
couldn't because it was locked. I couldn't get into it. So
Oh, it's locked. Okay, let me
yeah,
check.
yeah. Um,
Let's see.
so couldn't get
Mm-hmm.
into it. And
Okay, let
uh,
me see. So open it. Mm-hmm. So come assignment, assignment, homework 7. Oh, it's past due October 15. Okay.
it is past due. Yeah, absolutely.
Yeah, that's
Um,
okay. This one can be opened because this one is important. Oh, I extended until October 21st.
okay.
Yeah, but that's okay. Let's extend one more day, 22nd.
Yeah, we had the day that I got home and got all the way home, we had no access to Canvas because it crashed.
Ah, okay.
So
Okay.
so
I
that
I
day.
opened, extended the due date to 23rd. Okay.
Okay. That,
Okay, let's pick a one to look at. Actually, the exercise here is important because like a question one, let me share. As I think I'm talking myself. I need the sharing so you can see what I'm talking about. Um, where's my sharing button? Okay, here. Share. Right here. Okay. Can you see module 7? MO7
yeah.
homework. Yeah. You can pick. Which one is stuck? Question one?
Um, yeah, pick any of them. That would be good.
Okay. I think question one would be one good example to compare with homework exercise from chapter 6. Okay. 6,
Okay.
7. Yeah. Okay, let me use this one. Let me put this one. Okay. Let me bring to the whiteboard. The whiteboard. Okay. Oh, I need so are you seeing my whiteboard now or not yet?
No, I just see the questions.
Only questions.
Mhm.
Oh, I mean the question one, right?
Yes, I see it.
Oh, okay, good. I just try to bring over. So we have question here. Then we just solve it. Okay. This question one, I say it's good because the part A, we have two parts here to solve. Okay. And first part is just asking the probability that a single randomly selected value, that means anyone from the population we select. And what's the probability between these two numbers? Okay. And the
Okay.
second part, something different, is find the probability that a sample of the size, using the sample size of the 92, each time pick out the 92. Okay. So that's different. And central limit theorem tell us that if we use a sample size involved here, we need to do some work more to be able to apply normal probability distribution. Because chapter 6, like the part 1 here, or part, it's called part, okay, part 1. Part 1 is probability of 44.5 less than x less than 55.1. Okay. That's part 1. Okay.
Yeah.
Part 1 is expecting us find the probability for anyone in the population because it did not give us the sample size. Okay. That means anyone in one bigger population pick out one person. What will be the probability happen this way? Okay. So for this is the chapter 6 questions. Chapter 6 question is like this. Anyone you pick up from the population, no sample size involved. Okay. So to do this one, I think the easiest way is just apply a TI 8384. Do you have TI 84, right?
Mm-hmm.
Yeah. So let's learn the easiest way. Okay. Then what do you do? Just hit your calculator first. Second, mouse to call the second type of the function.
Yeah.
So I will look at my calculator same time as you. I hit the second vowels. Then I see normal PDF. Don't do that one. Select the number 2. Normal
See.
CDF. CDF. Okay. Because we want the calculator to calculate all the probability for us.
Four.
And when we come to work with the continuous random variable, those variables, that means our data involving with the decimals. And that means that we calculate 50, 50.1 or 50.2 decimal involved. Therefore, we need to use the CDF. CDF is cumulated ate up all the area. Okay. So you type on another one, then select another one. I will select number 2, enter. Now you need to enter X
44.
value.
Yeah.
Oh, yeah. We need to enter the value from where to where. Okay. Wait a moment, then I hit the wrong button. I told you no CDF, but I hit the 1. Let me clear all of this. Clear. Okay. What happened? I can't hear it. Okay. I hit the second box and
Yeah.
select the number 2, normal CDF, right?
Yeah.
Then now you need to enter what's the left side bound to, because we try to figure out the area. Follow kind of like it is. Let me draw quickly.
So 44.5?
Yeah, I will put the
Yeah.
lower bound, right? 44.5, and the upper bound, the greater number ending 50.1. Okay.
1. Yeah.
And the mean is 0. That's not true. Only G score we consider 0 and 1. But this is any data score. So you need to put the mean 58.9, the problem given to us here earlier. So first put the
58.9 and then 60.1, right?
then 50.1 and comma the mean. Okay, 58.9. Then the next number is the standard deviation, right? 60.1. So you just make sure you have all these 4 numbers: lower bound, upper bound, mean, and standard deviation. Okay. And standard deviation pretty big, 60.1. Okay, whatever they give to us, we just input the data. J.9, and I come to my calculator. 60.1. Okay. So making sure you have all these numbers correctly. So for the TI 83 and the older version of the TI 84, we do this way. You type in yourself. Okay. Then hit the enter. Okay. Enter.
Yeah.
Oh, you will see the answer already. Enter. What did you get?
I got 0.036473888.
That's right. Very good. So after you hit the enter, you will get the answer. You will get your answer already. Okay. 0.036 exactly said. Okay.
Yeah.
0.03647.
Yeah.
I have extra 6. Okay. 0.03647. Then we
Yeah.
look at the problem. Does the problem require me to do the rounding or not? Right? And look like the last sentence here said, enter, right? Enter your answer as a number is accurate to 4 decimal places. So they want us to round to 4 decimal. Okay. So then I will continue rounding. Okay, do rounding. So I do the rounding. That will give me approximately 0.03
365.
0365. Very good. Yeah. Because the fifth one is 7, right? And
Yep.
7 is greater than the 5. So we go up as 1 unit, adding to the 4. That's why it become 0365. Change
Okay.
our 4 to 5. Then that's your answer. Okay. So this is the one. This is from a chapter 6 question. Just use your calculator to do it. It's much easier than you have to look at the table. Okay. Well, anyway, now that's because if you use the table, you need to convert the X into the G score. And
Yeah.
go to the table, find out the corresponding area. Then you subtract each other. Okay. Just a lot of work. And the second part, problem said, find the probability that a sample size of n equals 92. So every time just pick a group of the people, 92, and to find the probability. This group of the sample here, what's the chance that their average will become, their mean is between same number, 44.5 and 50.1. But there's difference because this is sample of the 92 only.
Two.
Yeah, not anyone in the population. So when I do my second one, let me type here. Which I can just copy and paste. Oh,
So we just need to know the percentage of 92.
percentage.
Yeah. So we
No,
would, what the number is. Yeah. What?
no, you don't need a percentage. No,
Oh,
no, up to here. Okay, up to here
okay.
is well. we do the same thing. You type in the second vowel, same thing. Okay. Up to here, actually, it's almost the same. Okay. So I'm copy this one, put it here. Okay. You use the same function. Second vowels, normal CDF.
Okay.
And the lower bound is 44.5, upper bound is 50.1 because the same number. Then the mean is the same. That's what come to apply central limit theorem. Central limit theorem told us that the mean will be the same. The mean from the original population or the mean from sample. Okay, you do sampling every time, pick up 92, 92, 92. Then you check their average of the small group here, add all up and divide. We come out very close to the original one. So central limit theorem, that we have to keep in mind. The mean is the same. Okay, that's why I will keep the same number, 58.9. Okay, but standard deviation is different. Okay, standard deviation is not the same as 60.1 as the population. And because the sample is a sample and did not really represent the whole population. So what do we do? Statisticians suggested we should divide it by whatever sample size you have, okay, do adjustment.
Right.
So that's why came in. So I will do square root. I don't have the key here to type a square root. So I just write down SQRT is square root of,
Of 92
yeah, square root of the sample size.
of
Okay.
the sample size.
So sample size is a 92. Then I just involve in this one. Okay. So you can use a calculator to do together for you. Don't do separately. Okay. This way is much easier. We just need to remember the central limit theorem, just need to do adjustment of the standard deviation. That's the only thing we make the difference here. That the
Square root of
yeah,
2.
that our
0.59.
yeah, you have to divide by square root of the sample size. Okay, and this part is very important. Okay. Square root of sample size. I'm going to highlight to remind, we need to always remember to do that. Okay. Divide by square root of the sample size. Okay. So this is the application of the central limit theorem. Okay. Central limit theorem, only this part we need to pay attention. The mean is the same. Okay. But the standard deviation needs to be adjusted by sample size we use here. Okay. Because standard deviation from the population is different from just a group of the 92. So mathematicians, statisticians, they work out, they think the best way, just divide by square root of the sample size, and we make adjustment. Okay, so you try your calculator, you will see the answer different. It's different. Okay, so let me try mine. I will use all the same to count the standard deviation. Standard deviation, I will do more, right? I will do divide.
Oh, it's this. Okay, hold on.
Divide by, yeah, square root. Oh, sample size is 92. Okay.
Standard deviation is 60.1. Okay.
Yeah, but for second part, you need to divide by square root of the 92. Okay. That's because we use the sample of the 92 only, okay, each time. And after you have all these one, you hit the enter, you will come out answer, which is different.
Okay, I have to start over. Okay, second bar.
Mhm.
All right, so we've got 44, 5,
Did you get a different answer?
15. Hold on a second. I
Okay.
have to start over again.
No problem.
50.1, comma,
Mm-hmm.
58.9, comma, and then I got 0.6266.
0.0693. Right? Okay, it's a little bit different.
Okay.
Oh, we use the same one.
It's because it's the square root of n, right? So
Hmm.
that's square root of 92
Square root of 92.
is 95, 90.59. I mean, 9.59.
No, you don't need to find out the answer because if you find the answer, you didn't carry all the decimal to divide. So answer will come out slightly missing here. So the
Okay.
best way, just use your calculator and do 60.1 divided by square root of the 92.
Okie dokie.
Yeah, don't divide yourself. That's too
Oh, that's
many trouble and
okay.
decimal. Yeah. Uh-huh.
Divided by the square root of n.
Square root of the 92. And put it in a calculator. You don't need to find out that answer. Okay.
92. And then I close that.
Hmm.
0.093184412.
0.06931844. Very good. This time you got
Okay.
right.
Okay. Well, that's good to know. I've been trying to figure out the
Separately.
separately.
Oh, don't do it. That's why we use
Okay.
technology here. We don't want to bring another trouble here. Okay. Because when you do rounding, right, you already miss some decimal, right? Because
Yeah.
1 divided by square root of 92, you say a lot of decimal there. And
Yeah.
usually you just pick up 3 or 4, actually you lost all the decimal behind. But if you just enter in your calculator, they will include everything. So that's the best way you go. Okay.
Okay.
Hmm.
Yes, that is a lot easier.
Yeah, much easier, and they get the correct answer. Okay.
Divided by the square root of 92,
0 point, yeah.
which is, yeah,
So, so make
0.6.
a note. If the poem say we randomly select some sample size or something, that's always you use. Okay, divide by square root of the sample size. Okay,
Okay.
this is nice 3. They want to round it to 4 decimals, so 0.693. That's the answer.
0.693. Okay.
Mhm. Correct.
Hey. Well,
So chapter 7 is all talk about this. Okay.
yeah.
Chapter 7 is the when Paul say, oh, we randomly select something. Okay, that's a central limited theorem application here because we try to use our normal distribution for the sample sizes selected by certain sample size. But we need to do adjustment. Adjustment only this part, only the standard deviation. Yeah. Okay.
Hey.
All right. That's the important theorem. And because you are going to apply this theorem throughout the rest of the chapter now.
Yeah.
The rest of the chapter, everything is sampling. We randomly select something and to find out a probability. Okay. So, oh, that's fine.
Yeah. Chapter 8, we have, oh, yeah, the hypothesis testing. That's what's coming up next.
Well, that's coming. Yeah,
Yeah.
that's a highlight of this course, hypothesis testing. When you
Okay.
go to graduate school, they will require you to write a thesis or dissertation. We always apply hypothesis testing to
Okay.
propose something. And even you don't go to graduate school, you go to some company work. If you want to present something that you can do some proposal, usually if you use the hypothesis testing and show the company, if you follow my way, this one, you can make a profit like this. Our profit greater than some $1 million. Or you can show some evidence through hypothesis testing.
Okay.
Yeah. Okay, so any other question from other people here? Michelle, any question? No? Kiara,
No, I don't have anything.
do you have anyone? Any
No,
question? No. How about Jessica? if you have any question from your homework, we can take care first. Okay, so that help you to move on. The first one already. Any problem you have, if you have some example, you can based on that move on. If no questions, I'm going to use the question I posted in the discussions forum. Ask everyone to do the activity, which I call activity questions every week.
Okay.
So, these questions kind of were selected. Selected to practice the specific chapters or sections. So this is chapter 8. We have to remember one thing very important is we have 2 types. Actually, we have 3 types here. The first type is Pono asks you to estimate the population mean. Okay, so let me maybe write down these 3 important things. Number one is be able to estimate population proportion. Okay. And estimate population proportion, we had to learn the notation symbol as well. And we are population proportion, we use a small p. Okay. And we need to find out the 2 limits. Okay. We have like a book like to call lower bound. Okay. Lower bound on the left hand side. And how do we try to estimate for the whole bigger population in the middle and less than upper bound, some bigger number. So our estimation is always involving
Do you have this on the whiteboard? Or are you just explaining it?
So number 1 is estimate population proportion. And your final answer should show up like this. The low bound on the left-hand side. And the P, population mean, that's the notation of the population proportion, small p, okay? And less than upper bound, always right between the 2 number, okay? So we need to find out these 2 number. And happen to our TI 83, 84 can find this for us.
Do you have this written on the board?
Huh?
Do you have this on the whiteboard? Because I can't see it.
Oh, you cannot see it? I see. Let me see. Let me stop share. And let me share again. Okay. Share. Can you see now?
There we are. Yes.
Number 1, estimate population proportion. Yeah? Okay, good. This is the number 1 we needed to know. Okay. And your final answer should put on the left hand side, right hand side, you will come out 2 number. That's what we call low bound, upper bound. Just like in algebra class, we say, oh, we're looking for a solution. And in algebra, usually we will do something like this. Okay, my final answer come out 2 less than something, we put an x, right? In algebra, most time we use x. And between some other number 8, like that. The x estimate is between 2 and 8, like that. Okay. So what we do in statistical here, same thing. But we need to fit in using the right notation. For population proportion, we use small p. Okay. Then these 2 number, the ending 2 number, how can I find it? You can use a calculator, so easy. Okay. Let me see, we have example here. Yeah, the question 2. Okay, you can use the question 2. That's ask you to do to get your participation credit. Probably say out of the 300 people sampled and 102 had kids. Based on this one, we are going to construct a 99% confidence interval for the true population proportion of the people with the kids. So this is a good example how we estimate, right? So then how you estimate here is you can use your calculator. So easy. Okay. You got to learn this one today because if you know how to use technology, it's so simple. So first thing I do, I read the problem. I saw N sample size is 300 people, right? We have surveyed them. And 102 people said, yes, we have kids. And that's what we call success number, okay? Our expectation, right? Who we are searching on who have kids. So 102 had the kids. Among the 300 people, 102 people say, yes, we have kids. Okay. So that's you need to write down. Okay. N is 300, X is 102. Okay. And what more I need to know is how many percent of the confidence I want to provide. Because in the real world, what do we do? Usually we have 3 confidence level, 90%, 95%, and at least 99%. Okay. It depends on our research area. If you want the confidence interval smaller, then you need to provide like a 90% confidence. Okay. If you say, I just doing the research for the marketing, I want to reach out to more people. So you can make it 99% of the confidence. So depend research purpose. Okay. But the common one we do is a 90%, 95, 99. Remember these 3. And for this problem, it's a 99% confidence level. So I'm going to take my note, okay? Confidence level, CL equal 99%. Because you are going to use these 3 numbers to get answer, okay? And that's the most important number here. So after I have these 3 numbers noted here, I just come to my TI 83, 84. You just need to hit the calculator step, okay? Step. And move on to test. Because in the test here, we have this special formula inside, okay, for the proportion confidence interval formula. And you have to hit the right one, right? So you look down, first one is the G test, then we have T test, 2 sample GT test, and we don't need this. Move downward. I will see at the data size ABC, I can see 1 proportion, and this is what I need, 1 proportion. They only put the 1 prop, PROP, then Z, INT, stands for G interval, okay. Proportion, we always use the G interval. G score, because proportion we have count limitation. We need the minimum size to count the proportion here. If it's just 5 people, 3 people, we don't need a proportion here. Okay, so we have some determination here. Sample size must be greater than the normal one we do. So that's why we can use a G score, normal distribution, normal, bell-shaped data distributed. So pick up this step, test, and 1 plot Z interval, okay, and hit the enter. When you hit the enter, you will see the screen pop out, okay, asking what's the success number, X, and you just input the number. Earlier, I rated the problem is 102 hit, 102 people got the kids. And the next one is ask you how many sample size you interview here. N, so N is 300 people. So 300, I just type in. Okay. So change the number and 300. Then you can see the next question for you is asking you what's the confidence level. Okay. Then you can see the calculator step by step is leading you to input your data, C level. So if it's C level, I just type in 0.99 because 99% is 0.99. And the calculator requires you change to the decimal. Okay. So it's 0.99. That's coming from 99%. And we must remember percent means divide by 100. Okay. So that's how I convert to the decimal, 0.99. So if you have calculator, you can do together with me. Follow my instruction here. Place your calculator stat and move to the right, find the test. Then under the test, you will find out the going down, down, down. The letter A, one prop G int. That's the command to do the confidence interval for us. Okay. So if you have calculator, we can do together. Okay. Follow this. Okay. Stat, test, one prop G interval, enter. And enter X success number as 102, sample size N as 300, and confidence level as 0.99. Okay, so enter all these data given to you, then you can go to calculate. Okay? This one just calculate. We commanding the calculator to do for us. So when you hit the calculator and press enter, right? Confirm. Yeah, that's the one. Okay. Enter. Then you should get the answer already. We give you one parenthesis, 0.26955, comma, 0.41045. I hope you get the same answer. Okay.
And then it says P.34.
And then the problem said we want to express our final solution as the low bound, that format. Okay.
Oh, so we would write it out
You-
0.26955 P.34.
Yeah, you will write it like this, 0.270, because probably is rounded to 3 decimal, right? And
Okay.
when I rounded to 3 decimal, I look at the 5, you can go up 18 to the 9, become the 10. So that's why it becomes 0, right? The
270
answer will be 0.270.
is less than.
Then it's less than, and put a small p in the middle, and
Yeah.
less than the upper bound. I'm going to do the rounding again. So I count 1, 2, 3, 4. The fourth decimal is a 4, less than 5. So I can just drop. Whatever behind it, just drop. You don't need to care. So my answer will come out 0.410. I get done. Okay. And you say, wow, do I need to write it down to 0? Yes. If the problem said ask you to round it to 3, and when people saw you wrote a 0 behind, that's what tell the people that in our solution, we round off. Okay. We're supposed to have more decimal, but we keep the 0 there, tell the people, I round off the 3 decimal. Okay. So that's this message here. So I need to keep like this. So when we present the confidence interval, you can use a parenthesis, like a calculator is use a parenthesis, okay? And like our book is showing the P, put it in the middle and greater than the lower bound, in between the lower bound and upper bound, okay? So that's how you present. And actually we have one more way to show it. Is sample mean plus or minus plus or minus the second part. Let me see where I have this. Yeah, plus or minus. We call modular error. Okay, error. But this is one of the 3 ways we can present. But if I'm going to present another way, sometimes the question asks you, what is, right? What is the margin of error? That means this is the estimation. And when we do the estimation, we could commit some mistake. Okay. So in statistics, already set up some margin of error, minimum error could happen. And we have formula for that. Okay. So what is this minimum error could occur? You can either use the formula like E representing the error. Okay, equal. You can use the formula, but if you have calculator, I will show you an easy way to get this modular error. But in case you don't have a confidence interval, you need to follow this. Critical value, okay, we need, then involved with the critical value is more complicated. So you need to count G, critical value, and multiply, you need to multiply, use parentheses for multiply. Multiply, you need to type in what's the P hat, the sample proportion, and multiply Q hat, and divided by sample size, square root of sample size. This is the application of the central limit theorems here. So the whole thing, we need to go to the square root, okay? So I should write down square root of this expression here, P times Q times divided by sample size. That's the error formula. You can see the book give you that one. But since you have TI-83, 84, I can just find out from here without applying the formula. You can take the upper bound, okay? This one, 0.41045 minus, pick up the bigger number and subtract out the p hat. P hat, the sample proportion. And our calculator also show p hat. You can see the calculator will show you p hat. It's 0.34. Okay. Why you get all this result here? When you hit enter, besides the confidence interval, they also show us p hat, sample proportion. Will give us 0.34. And how did I get this number? Actually, it's coming from this. I can show you from where it came from. It's from 102 divided by 300. That's how we got this 0.34. And that's what we call simple proportion. Okay. So you can try out 102 divided by 300. Yeah. You should get the same answer, divided by 300. I come out of 0.34. Okay. So you just take this upper bound calculator says 0.41045, subtract out another 0.34. 0.34. So the difference is a margin of the error. Okay. 0.41045 minus 0.34. I got the 0.07045. And I round to 3 decimal would be 0.070. That's the error of our estimation. So for those of you who have the TI-8384 calculator, when the problem asks you to find out the margin of the error, okay, involving our estimation, just pick up the bigger number and subtract out the p hat. That we call p hat, okay? P with a hat on the top, sample proportion. It will give you immediately. That's the answer. You don't need to go through that formula, because the formula is kind of more step you have to go, and you need to multiply with the critical value here. And to find out this critical value, it's not easy. You have to get it right? So I would prefer you learn this way. Just take the upper bound, subtract the p hat, will give you the remaining difference. That's the modular error while we're doing the estimate. Okay. So this is a good example to show you first type of the problem we have is the estimation of the population proportion. And you follow this way to do it. And for the population proportion, we have one more thing is important. It's how you find out the sample size. Suppose one day you work for some company, and some company say, yeah, you got a degree, from the college, you should have done statistics, right? So you need our team here to do the marketing research. And but if you are the leader to take the team to do the research outside, you need to request the money, right? The budget to spend. And but the budget, the money you request first is based on how many sample size we need to interview the people. If you interview 300 people, you have to spend maybe 30 days to finish. But if you interview just 30 people, not of course, then maybe you finish in 1 day. That's different. That's why we need a kind of pre-estimate, right? Before we going out to conducting the research study. So this one is the one, sample size. I wrote somewhere here. I think I put it here. Let me move this around. Huh? This one like to stay, doesn't want to move. Okay. You see, I wrote here, sample size formula. Okay. But that formula is for the mean. We estimate the mean for the mean. For estimating the mean. You know, our chapter 8 kind of changed the subject a lot, but your final exam is only cover starting chapter 8. Okay, but of course we will use the central limited theory from the chapter 7. Okay, all the way. But question focus is from your chapter 8, 9, 10. No, we skip the 10. Chapter 8, chapter 9, skip the 10 and go 11, 12, 13. So it's the last chapter, okay, your final. And one of the formula you need to know is about this sample size, how you pre-estimate, right, to request your budget money. So I'm going to show you this one. This one is for proportion. So you have to use the proportion formula here. And this is the formula. Okay, move over. Okay, sample size formula. The one here, the one in the blue frame, not this one. I try to move this away. Okay, move away. This is for the mean. For the proportion, we should use this one in the blue frame. That means sample size is equal G alpha over 2. That means our significance level, you have to divide by 2. That's why I say if you use traditional way looking for the table, it's more complicated. You need to be able to find out what's the critical value. This is G alpha over 2. Then multiply P prime, they use a prime, actually same as a P hat, same thing. And Q prime could be the Q hat, okay? And divided by EBP. The book uses EBP. It's an error-bounded proportion, okay? It's but most books just say marginal error or just say error, okay? Easier way. So E is error, and P is for proportion. That's it. But the whole thing you need to go to the square power, okay? So that's why I prefer you could apply differently, like this way here. I'm going to use the question 1 to show you as an example, okay? Show you how you apply. Okay. So question 1 says a political candidate has asked you to conduct a poll to determine what percentage of the people support her. If the candidate only wants a 3% marginal error, you see, the real word, they like just use a marginal error. At the 95% confidence level, what size of the sample is needed? And we need to show the sample size. So sample size N, right? We type in, I just want to N once, but how come so long? Okay. N equal, and I would prefer doing it, put the parenthesis already, okay? Then the critical value, remember the formula here says G alpha over 2 multiply P prime, Q prime. Okay. So that means the critical value you need to bring in. So what's the critical value? You have to look at the 95%. How many percent of the confidence we have? And our confidence level, right, CL, is equal 95%, which is given, usually is given. So 95%, the critical value is the critical value is G, that is the notation. Then they put alpha over 2, just type A over 2 like that. Okay, that's the notation. Then critical value, actually you can memorize this or you can prepare on your page of the note, bring to the exam time. 1.95. Okay. We always know that's 1.95. You can calculate that, but you don't need to waste time for that. You just take as part of your note. Okay. When Paul mentioned 95%, critical value is 1.95. Okay. And maybe I write more here. If the critical value, okay, your critical value is, Paul says 90% only. Okay. Then the critical value is different. Critical value for 90% is 1.645. Again, you can use a table to find it, or you can use your graphing calculator to find it. But you can just write down on your note, okay? Because this is the common use that confidence level we do in the real world. And we just take as part of the part of the formula you should know already. But you can write down on your page or the note, okay? For 90%, use 1.645, okay? And if confidence level changed to 99%, okay, like the one we did earlier is 99%, then you need to use this number. Your critical value G, G alpha over 2, okay? That's a notation for critical value. So you can write a critical value or G alpha over 2 is 2.575. And I know some book they use 2.576. That's just because they use technology. And by rounding, there's some more decimal behind it. They go up, become 2.576. You will see somewhere, you may see that. But in our class, I would suggest you just use the 2.575 in order to make the answer key, okay? So that way, I don't want the exam time because one decimal difference, your answer is different. All right, use this 3 number, okay? And my exam question, I usually adopt 95% or 90% or 99%. I only use these 3 common used level. Not to give the student trouble here, because some homework exercise, maybe 82%, maybe 96%, something off our number. But for our midterm is not midterm, our final exam, I will use this one, okay? Because the problem will ask you to find a sample size. And I will type in 2.5, no, for this problem, example question 2, yeah, it's 99%. So if 99%, no,
So
I'm doing the question 1, right? Sorry. Question
one.
1 is 95%. So 1.96. So I will just type in 1.96. Okay. Hey, let's come and put a 1.95 there. Sometimes I think something and wrote it differently. So for write down, double check again. For 95% is 1.96. And that's a correct number. And some textbook, they came with this number for the student to use as a table. Okay. So it's kind of given to you. 1.96, yeah. So yeah, write down these three number, okay? Okay, so I'm going to show you how can I finish this one here. Wow. How can I undo this one? Undo. Okay. So I have 1.96. I will continue. Okay. We need a simple critical value. Okay. And multiply p hat. Okay. And p hat is given or not. Look at the question one. Papa didn't say how many percent of the people will vote for her. The prior knowledge is not provided. There is candidates maybe first time running. And so if first time running, Paul didn't tell us what is the p hat or what is the p prime. You just assume 0.5, okay? 50% of the chance people will vote for her or not vote for her. Use 0.5. That's what the formula suggests. Use 0.5. When you read the problem, there's no other percent here from the past. So use the 0.5 to replace p hat, p prime, and multiply one more 0.5 for the q prime. Okay. You can do this, or you don't need all this one. You can just type 1, it's okay. You know why? Because they are same number, but later I show you, yeah, all the number. Because sometimes they can tell us it's 0.7, 0.6, point some different number, okay? So whatever they give to us, okay. Parenthesis 1.96, then divide by EBP is an arrow bounded to the proportion. And Papa said the candidate only wants 3% of modular error. She wanted this estimation involved only 3% error only. So 3% error, you have to convert to the 0.03. Okay. A lot of people make a mistake of this type of the problem. They just put a 3. No. When you are given 3% of the modular error, you have to remember, take a 3, divide by 100, and get a 0.03. Okay. Then close it, and the whole thing go to square power. Okay. You need to go square power. And you need to multiply with the p hat and or p prime, the sample proportion. But Papa didn't say anything because she didn't run. She's first time running. We don't know anything earlier before. So you would just use 0.5, 50% of the chance people will vote for her. And Q, of course, will be 0.5, right? 50% vote for her, and another 50% will not. So you just do this way, okay? So for this example 1, question 1, I will just do 1.96 and divided by 0.003. No, too many zero. Okay. 0.03. Then close parenthesis. Then hit the square power. Then multiply 0.25. Because I know 0.5 times 0.5 is 0.25. Then equal enter, right? You will get your answer already. So 1.96 divided by 0.03, whole thing go to square and multiply 0.25 equal. You should have come out with some number, very interesting number. That's 1,067 people will vote for her. Okay. Sample size. She wants to conducting the survey. Okay. So she wants to determine how many sample size we need to interview people. And according to our statistical formula here, shows she needs at least 1,068 people, not 7 people, okay? Not 1,067. So when you come out another decimal behind, even the 0.1, okay? If I round it to one decimal, 0.1, you still have to count that the 0.1 as one individual sample, okay? So the final answer should be this one, 1,068 people, okay? We need to select the 1,068 people to cover that minimum requirement through the algebra formula, okay? So you can put an important note here, note. Always round up the answer to a whole number. Round up, not round down, okay? Always just round up to a whole number as sample size. This is so important, okay? Because our final exam, I often find that people apply the formula correctly, did everything correctly, but the final answer is wrong. Instead of give me 1,068 people, give me 1,067.1. Not a 0.1. We cannot write a 0.1 because in reality, we cannot have 0.1 person. You just have to round as one person, one individual. So this is so important. I want everybody pay attention to this, okay? In the final exam, when we come to the final exam or your test, right? Your online test, you still have online test, chapter 8, chapter 9 coming up. And when Papa asks you sample size, always round up to the whole number, okay? Even the decimal so small, 0.1 there, 0.1, right? You still go up, okay? Just remember what I say here. Because in order to satisfy that the minimum error, 3%, we need to make our sample size count as a whole number like that, okay? More sample size, our margin error is smaller. So you cannot take off any decimal behind. When you take off, our margin of error will be affected and changed. Okay. So today we have mentioned something very important here. Okay. How you find the confidence interval and how you find the sample size. And when you find the sample size, always remember round up to the next whole number. Okay. I hope everyone remember this, round up. Okay? Because that's the common mistake on the exam all the time. And once upon a time, I have 3 questions of the sample size on the final exam. So a person, I remember that the person missed 30, each question is 20 points, right? The total is 300 points. And we have 15 questions. So each question is kind of worth of the 20 points. So 20 times 3, that's a 60 point. That's a lot of loss here. And so I hope everyone remember this rule here. Round up your answer to the whole number as a whole sample size. Okay. Okay. So today you may start working on this part, right? And use my example I show you here to work out question 1 and question 2. Question 3 is something different. Question 3 is involving with confidence interval, 90% confidence. And we are going to construct confidence interval for this situation. And this situation didn't say any word is for proportion or for the mean. But you can pick up from the problem set here. If sample size is 14, X bar is 34. Remember, X bar means, right? X bar means the sample mean. So when they use the sample mean, it asks you to estimate population mean. So chapter 8 here, we are doing something backwards, okay? Before, we always try to find out information from the population. But now we are using the sample information to estimate what the big population should look like, okay? So for the question 3, we can quickly finish this one so you have more example to follow up. So for question 3, because X bar is given, okay? I just got an idea from the X bar. So for Q3, I know this one must be estimate the population, mean, average, okay? That's why they use S bar, okay? And since I got that idea, we need to find out the population mean. Good. To find the population mean, we have two tools to do it. One is G interval, the other one is T interval. In the calculator, also divide these two for you. But when I should use the G interval, yeah, when I should use the T interval, it depends, okay? Depends. You have to look at depends on sigma, okay? Population standard. Standard deviation. Depend. This one, whether this one is given or not, okay? Depend the population standard deviation is given or not, okay? If it's given, if given, okay? If given, you will use your calculator there, same thing as we did earlier, move to the test and select, okay? Select, you will select the G interval, okay? Select G interval, G interval. If it's not given, otherwise, you will use T interval. Just follow this rule. You should be able to do it, okay? And I think that's it for today. We'll just cover like this. So that may, at least will help you to start working on something, your homework. And while you are studying, make a sense to you, okay? This is the rule you need to follow, okay? So for the question 3, I will use a T interval because the population standard deviation sigma is not given. You can read the problem only give me small x. When the problem give me a small x, I use a T interval, okay? So that's it. What do you do, okay? So to do the question 3, I can quickly do together with you. You will hit the stat, right? And go to the test and select the T interval just because small x is given and sigma is not given. Population standard deviation is not here. So I choose the T interval. And when you choose T interval, the input, this data and the state, select the states, okay? Because the X bar is given. Then you highlight on the states, then enter the data of the X bar, which is 34, and small x, simple standard deviation is given as 9, and sample size is given as 14, and confidence level is 90%, so I change it to 0.90, 0.9, and calculate. I should get the answer already, and you should do same thing as I do. So for this one here, you just choose a T interval, and you should be able to get an interval like this, 29.74, comma, 38.26. My calculator show me this answer here, okay? And I think that's it, right? So remember, this is something you need to remember here, okay? Sigma is the one decide you are going to use a G or use a T, okay? Sigma given, use a G. Sigma you don't see anywhere, and only show you the small x, use T interval, okay? Because the distribution are different. One is count more sample size, big one, normal distribution. And t-distribution is for smaller sample size, and whole population situation is not given. Sigma is unknown. So that's why we use a t-interval. Okay. So I hope you take notes and write down the sample size formula, because that's the important things for the chapter 8. Okay. And hope you continue working on chapter 8. And if you come up with any question, put on the discussion board. I will help you there. Okay. Or you can share with me next week, next Wednesday. Okay. All right. So see you next time, next week.
Thank you.
You're welcome. Bye-bye, everyone.